Hi, and welcome to a video on finding the extreme values. We're going to use calculus in this video to find the extreme values of our function. And before we do that, we need to look at the domain of this function. So if we consider the domain of f, we need to look at the denominator first of all, and notice that the denominator cannot equal 0, and what's under the square root sign has to be greater than 0. So we end up with something like this: 4 minus x squared has to be greater than 0. So if we solve this, we'll get the domain of our function. So what this means is that x has to be greater than -2 or less than 2, and this is our domain of f. Now that we've figured out the domain, we can go ahead and take the derivative of the function. If you will recall, we get extreme values where the derivative of the function equals 0 or does not exist. And these are only possible places where extreme values might exist. They don't always have to be extreme values. After we figure out where the derivative equals 0 or does not exist, we actually need to check those values to see if they are max or mins or neither. So let's go ahead and do this. First thing we need to do is take the derivative, and before I do that, I'm going to rewrite this so that it's a little bit easier to take the derivative of. I'm going to put the denominator in the numerator and rewrite it 4 minus x squared. And a root is a 1/2 power, and since we're putting it upstairs, it's going to be a -1/2 power, and that makes it a lot easier to take the derivative. So f prime of x, now I can use the chain rule, is -1/2 times the quantity 4 minus x squared to the -3/2, and then we have to use the chain rule, which is -2x. And then after I simplify this, I'm going to get something a little bit easier to look at, so let me quickly do that. And some things simplify here. I had a negative sign down here, so those two negatives will make a positive, and my final derivative is going to look like this: x in the numerator and the square root of 4 minus x squared to the 3rd power. Now, to get the zeros of the function, or where the derivative equals 0, we're going to set the numerator equal to 0. So for that, that's pretty simple. We get x equals 0. This is one of the critical points. This is a place where we may have a max or a min. And then to get our does not exist, we're going to let the denominator equal 0. And when we solve the denominator equal to 0, we end up with x equals positive or -2. But if you look back into the domain of f, x cannot actually equal positive or -2, so we don't even have to worry about these because they are not in the domain of f. So all we're really looking at in this problem is this particular critical point on the function's domain, and recall the function's domain goes from -2 to 2, and we've got a critical point of 0, and this is where the derivative equals 0. So this is a sign chart for the derivative. I'm going to label this the derivative of f, and what we need to do is pick a test point here. And a good test point here is -1. So if we plug -1 back into our derivative, and that would be over here, if we put in -1, we're going to get, oh, I need an f prime up here. That should be f prime. F prime of -1 is going to get us -1 over, and this is going to be a positive value. So we don't really need to evaluate this. You just need to figure out the sign. Sorry, it's going to be a negative value. The numerator is negative, the denominator is positive, so this is going to be negative. If f prime is negative, that means our function is decreasing. So in this interval, our function is decreasing. The next thing we want to do is we want to pick a test point in this interval. So let's test x equal 1, and to do that, we want to look at the derivative at 1. And if we put 1 in everywhere we see an x, we do 1 over 4 minus 1 to the 3rd power, and this is going to yield a positive value because a positive divided by a positive is a positive. So on this interval, our derivative is positive, which means our function is increasing. So we must have a minimum value right here at x equals 0. Now, this is just the location of our minimum value. It's not the minimum value. To find the minimum value, you must plug 0 back into your function. So to find the minimum, we're going to do f of 0, and you're going back to the original function. And if we look back at the original function, we have 1 over the square root of 4 minus 0 squared, which yields 1/2. So we have a minimum value of 1/2, and it happens at x equals 0. And if we want to look at the graph, we can verify this graphically. So let me go ahead and pick up the graph and we can see what's going on there. So here's a graph of the function. I put the y equals that we were using into our function, and I looked at the graph, and you can see that we do have the domain from -2 to 2, and that's an open interval, and then we have a minimum value at 0. So what our minimum value here is 1/2 right at 0. So everything we've done here agrees. Make sure that you know the difference between where the minimum value happens and what the minimum value is. So the minimum value is the y value, where it happens is the x value. I hope this helped. Keep watching.